chromatic number can be described as the minimum number of colors needed to color a graph so that no edges connect vertices of the same color. This is also called proper coloring, which is when no edges joins vertices of the same color. As you can see in the image, when the lines connect two vertices, they are connecting two vertices of different colors and not the same color. For example, it goes from blue to red or blue to green. This means that this image is proper colored. When doing this process, you're looking for the chromatic number. The chromatic number is how many different colors it takes to color the graph properly. In general, there is no effective method to finding the chromatic number of a graph, but there are theorems that tell us whether a graph is two-colorable, which will be further explained on a later slide.
Colorable graph theorem. A graph is considered two-colorable if and only if it has no surface that consists of an odd number of vertices. Also, the graph cannot connect vertices of the same color. If so, the two-colorable theorem cannot be applied. For the example below, vertices A, B, and C are not connected to the same color, being blue, as X, Y, and Z, which are not connected to the same color, that being red. This shows that the two-colorable theorem can be applied for this graph.
So we have a thing called non-planar graphs that we're also talking about in our slides. A non-planar graph cannot be drawn in a plane without any edges intersecting each other. So essentially this means that it is a graph that requires edge crossings when you try to represent it. So this typically is seen with a K5 or a K33, which is of course the subdivision, would be non-planar. They also don't satisfy the formula of b minus e plus f, which equals 2. This is Ulcer's formula, so essentially non-planar graphs don't occur often because most of the time you can make it planar. However, there's those few exceptions like what I mentioned before that makes it, essential or available, I should say, to make that happen.
Hello and welcome to this slide where we are talking about planar graphs. And planar graphs are essentially graphs with edges that do not cross. It allows for much easier coloring or numbering to find the chromatic number. And see, we have an example right here where one edge is added to make the chromatic number jump from 2 to 3. And in this example that I am working through right here, I am coloring the different vertexes, with each of them being a different color that does not match based on the edge that connects them. This first example is on a non-planar graph because there are edges that cross. And then the next example that I have is planar and was a lot easier to do. Real-world application as well includes different things such as scheduling, designing buildings, and also seating charts. So that's pretty fun as well. Hope you enjoyed this slide and this project.